to get them bootstrapped into the internet, to talk about what we'd learned and what we'd done in the last few years, and hope that they would be inspired too. We didn't know what we were doing. And it was pretty clear that no one knew what they were doing. The internet was very young. We really thought the telephone companies would take over and tell us what to do. But that didn't happen. We became the internet of the world. We're mainstream. And you kind of go, well, that's easy now. Now we know what we're doing. We don't. We don't know what we're doing. So to all of you engineers out there, let me say this. We really don't know what we're doing. If you don't like something on the internet, change it. Change it. Because it doesn't have to be like this. Everything that you do, we can change, and we are changing it. At the time, in 1994, the big issues were all about transits and long-distance cabling and TCP. What's today's conversation? Cybersecurity, content data networking, 5G. The conversations keep changing, and our knowledge has to keep changing too. As engineers, we expect you to know it all, but we expect more. We expect you to change what you don't like. If you don't like it, don't put up with it, change it. And some of the most amazing bits of software have come from places no one ever thought possible. Where was Skype developed? Estonia. Who would have thought? Good technical people are all over the world. You're in this room. If you don't like it, change it. It's only software. So what I want to talk to you today is about the domain name system and privacy, and how we're currently changing the network, how we're making it different. Now, why am I talking about this? Why the domain name system? What makes a network? Wires? Well, no, not really, because you can speak one protocol and I can speak another protocol. So wires don't really make it work. What about IP addresses? I mean, is the addressing system the fundamental basis? No, we broke that. Here in Mongolia, there are around 700,000 users of the internet, as far as I can tell. Might be more. But you only have 260,000 IP addresses. So obviously, not everyone has an IP address all the time. You're sharing addresses. So we broke addressing. Addressing doesn't make the internet. What makes the internet? What's the one thing that allows me to refer to something like my website and for you to go to the same website? It's the domain name system. It's the DNS. The DNS is the glue that keeps the entire net together. It's really important. So I was clicking onto the next slide, but there it is. It's really important. I like this slide because I think it's true. The one thing that Google, they did lots of things, of course. Global search, Gmail, Google Docs. But interestingly, the one that's touched everything is the DNS. And it's the richest source of information about what you and I do. Because everything we do on the internet, even getting ads delivered, requires a call to the DNS. And if I saw your DNS stream, I know you. I know everything you're doing right now. So this is really important. The DNS is critical. I keep on jumping the wrong way. Oh, it's down there. So everything you do starts on the DNS. The problem is that everyone else knows it too. Who's looking over your shoulder? I mean, Google seems to. What about others? How much of the internet sort of starts with a little bit of peering? We thought we'd look at this because it's kind of interesting. What if I gave you a domain name that has never existed before and will never exist again? What if I gave you a domain name that you only use once and only once? What if that name includes the time, so I know when this name got created? It's only used once and the time is in it. And what if I'm the only authoritative server on the planet that knows how to translate that name? So when you get this name and you try and resolve it, something talks to me. So I see you. So I should only see the name once, right? Just once. But I don't. So here's the kind of name we're looking at. Did you realise what you can put in the DNS? I bet you didn't. Here's a domain name. This is the time of day. This is your IP address. This is the country where you're living. All of this in the domain name. So I know you. And when you give me that name, I can see you do it. So I can distinguish between the initial query and someone looking over my shoulder. Someone looking at me, sort of doing it again. And the problem is, the internet is full of people looking at you and I, all the time. 1 in 20 people on the internet seem to have a digital stalker, someone who's looking at what they're doing and repeating the query more than 30 seconds afterwards. Every single day we see it again and again and again. Around about 5% of users have attracted this kind of stalking. Now, maybe your DNS is really, really slow and it takes 30 seconds. You're not doing the right job if your DNS takes 30 seconds. Do something else. Because the DNS should be lightning fast. It should be really quick. So why am I getting these queries? What's going on? I started looking because, like you, I'm interested. I want to understand why. Because I actually don't like people looking at my queries. I think that's wrong. So I started looking at what's the query rate of the stalkers. So the purple's just the normal rate of queries that I get. That green is the replays. And you notice that most of the time it's low, and then all of a sudden someone sends me 10,000 queries per second. Someone's accumulated a log of the DNS and is replaying it through something like Amazon. Really fast machinery. And it's odd. Sometimes it happens within a second. This is time. I go somewhere, something asks again. That's scary. That's real time. But other times, it's been a month ago, 2 months ago, 6 months ago, a year ago. Whenever I do something, someone remembers forever. The DNS seems to accumulate everything for a huge amount of time. Years old, that data is still in the DNS. So people are looking at the DNS and seeing what we do. Who? So here are the IP addresses of the people who are replaying DNS, as far as I can see. This is the country, and this is the name of the network that hosts what they're doing. You will see that some countries tend to dominate in this area. There's one south of here. Google also figures high in that list. And a Canadian, because the Canadian's number 25. What's going on? Why? Is it something to do with people looking in our network? Or is it the applications that we're using? What's going on? Well, interestingly, what I found in looking again and again and again is that in one particular case, your keyboards aren't good enough. I suppose most of you use US ASCII keyboards. How do you type Cyrillic or the Mongolian script? It's hard. And sometimes you use a browser or an application that translates for you. There was a really good one for Chinese speakers called, now my pronunciation might be bad, Sogu. It's one of the few browsers that does pinyin. But every single time you go to a new website, the Sogu system does it again. It's stalking you. Your own browser is giving it away. Don't use it. If this is the one you're using, find another browser. It's not very good. But it's more than that. This is a tiny glimpse into the fact that the most valuable source of information about what we do, things that drive today's internet of understanding the way we do things and what we're doing, the DNS is part of this. So, can we stop it? I doubt it. Folk will always look, whether it's Google, whether it's any of the data people, or whether it's countries. Well, they'll keep on doing it. But we can make it harder. You and I can make this harder. So the issue is almost everyone currently gets to see what we're doing in the DNS. How? You might think that domain name systems are simple. I'm a customer of Mobicom. Mobicom run a DNS resolver. That machine goes and asks questions on my behalf. I get back answers. Yes? No, nothing like that. There's an extraordinary amount of machinery. There are server farms, there are forwarders, there are weird loops. And almost every part of that process you can look at. You can sit there and be bad. You can run an application like Sogu that just tells someone else everything you do. You can sit on the wire or on the radio network between the user and their base station and look at what's happening there, because the DNS isn't encrypted. Everything you do on Wi-Fi and the DNS, I can see it too. Everyone can see it. It's in the clear. Resolvers collect logs and they sell them because it's more money. So they sell the log. And over here at the authoritative server, they collect logs and sell them. So at every part of the DNS, people are bad. People are leaking your data and my data. So the problem is the protocol. When we designed this stuff in 1994 and earlier, we never thought about encryption. We thought we could trust each other. Everyone was friendly. They're not. We shouldn't have. The DNS is unencrypted. It is really easy to tamper with. The DNS is opaque. You can't tell what's going on. You send a question, stuff happens, you get back an answer. Love the answer. Who saw the question? I don't know. Is the answer real? I don't know. Try asking for www.facebook.com in the country to south of here and you see what I mean. That sometimes the answers aren't real. So the DNS is used by everyone, but it's never very good. And some people make a living out of looking over your shoulder. This is a company run by Paul Vixie, one of the fathers of the DNS, and he's now gone into selling intelligence based around DNS queries, because the DNS knows more about the internet than anything else. This is not right. We can do a better job. We should do a better job. You should be able to trust the internet because you trust it anyway. Every time you do stuff on the internet, everyone's looking. That's not right. We should be able to trust it. So the first thing, the DNS was not designed to be secure. It tells too many people too much. If I wanted to go to mysecretdomainname.geoff.com, I will tell the root service, I will tell the .com service, I will tell everybody in the DNS my secret domain name. Isn't that stupid? Maybe I should do something a bit better. Why are we telling all these secrets? What I really should do is just tell enough. Use a thing called query minimization. That instead of telling everybody, I just tell enough. So if I want to know a domain server, for example, .com, I should only tell the minimum part to the root. The minimum part, the minimum part. It's out there. It's called QNAME minimization. In Madagascar, 76% of users now sit behind DNS resolvers that protect their users. In Mongolia, none. None. But it's available. It's in all the current resolver software. Turn it on. Why? Because privacy is important. Don't just think, oh yeah, well, the current version's good enough, I shouldn't bother turning this on. Look after your users and protect them. So globally, only 3% of users all around the planet are protected in this way. That's about 97% too small. We all should be doing this. We all know how. Why aren't we doing it? And what about interception and rewriting? Speaking of China, every country has lists of bad things. In Australia, the Pirate Bay, because of internet copyright and theft, is on the bad list, and Facebook in China. And sometimes, like in China, when you ask for these names, you get back the wrong answer. Hi, I'm Facebook. My address is 1.1.1.1. That's bad. So we can do better with DNSSEC, with encryption for the DNS. Because once I start doing genuine signatures, when I get back an answer, I know if it's the right answer or not. DNS can't tell you what the right answer is if you get a bad one, but it can certainly tell you that was wrong. Very important. So DNS can actually look at this signature and say, is what I got the real thing? Is that the genuine answer or not? Now, some of these big open resolvers, Cloudflare on 1.1.1.1, Google on all 8s, Quad 9 on all 9s, they do it. So if you switch to use them, you will get DNSSEC for free. Because when it resolves, it's the genuine answer. No one's rewriting it for you. What about Mongolia? This is interesting. We know who. In about January of 2018, someone turned it on. Not everyone, someone. So a fair deal of the country, and by fair deal, I mean around 2/3 of your users have DNSSEC. The other third don't. Here they are. AS 17882, you're in the room, aren't you? I'm not, it's you. 97% validate, well done. Mobicom, they're our platinum sponsor. I'm sure you're going to get there. It might take a bit of time, but you will get there. Sky, you're getting there. MobiNet, not Mobicom, MobiNet, 9484, yes, absolutely. So it's not quite everyone, but 2 of the biggies are there. The rest need to do a bit more work. So that's what you're doing in DNSSEC. The next thing, this is the leading edge of the DNS. This is the bit where we're working today. The DNS is a protocol that isn't encrypted. Everybody can look. I can look at your messages even a year later and still understand them. We need to do better. When you run a web page, do you use Let's Encrypt certificates? Yes. Do you run HTTPS? Yes. Do you run TLS? Yes. If anyone said no, you need to do some work right now because you've got to encrypt. But if you've got to encrypt on the web, you've got to encrypt in the DNS as well. Let's do this. Let's actually put transport level security into the DNS. And there are tools to do this. So the first one is DNS over TLS. Everything that goes between me and the resolver is encrypted. No one else can see it. No one can change it. I have an Android phone sitting down there. and I turned on a thing called private DNS. Now, what that actually means is I turned on DNS over TLS. So now, out of that handset, every DNS query is protected through encryption. No one else can look at what I'm doing, even on Wi-Fi, and figure out what I said. If you've got Android, version 9 or later, turn it on. It's to protect you. It's to make sure that what you're doing is your secrets, no one else's. So DNS over TLS and Android, it's there. What's happening with iOS and Apple? Well, I don't know. Apple, oh, there's an Apple store coming soon. Go down and tell them what you want, because this isn't good enough. They should be doing it too. So there's a little bit more recursive load in doing this, but you're protecting users. Now, the recursive resolver still knows all your secrets, and that's a different issue, but it's widely available. You should be turning this on, you should be doing it. And if you're a mobile provider, and you're running something like Bind, or Not, or Unbound, you should offer that as a service back to your Android users, that your Android users can contact you securely for the DNS. I don't know if any of you have been following Google lately, but if you're from the carrier world, Google doesn't like you. Google thinks they mess with their packets. Google think you're looking. Google are going to stop that. If you're running Chrome, Chrome now has a new transport protocol called QUIC. It runs in UDP, not TCP, and everything is encrypted. So if you're here even in Mongolia and using Chrome and you go to google.com, it will try and use QUIC. It will encrypt everything. That's great, let's do it for the DNS. And someone's already started this. Christian Huitma has actually taken the open source code and done DNS over QUIC. Let me say that sentence once more, because you have a lot of technical kids here who are going through university who are learning about this technology. Christian took open source code for both the DNS and QUIC and put them together. You could have done it too. You should be looking at that. It's not that Christian lives in Seattle, it's that he just saw that and said, I can do that. You should look at these things as opportunities for you to also do this kind of work. Open source is there for you as much as everyone else. So this isn't a big corporate effort, it's just one guy said, wow, using QUIC is really cool, let's do it. And if you aren't thinking, oh, what will I do because I'm really interested in the internet, go and look at QUIC. QUIC is amazing. It's open source code, it's really exciting stuff. It's what's happening today on the internet, right now. The other thing that's happening today at the internet right now, which is exciting a lot of comment, is DNS over HTTPS. You thought HTTPS was only for web pages? No, it's just a transport protocol. So you can just put DNS queries in it. Instead of a web page, you get back an answer. Firefox has done this. And Firefox is turning it on as we speak. So if you're using Firefox, you might well find that the resolver you're using is not the resolver your ISP has provided. Because Firefox is now saying when you run Firefox, its DNS queries go encrypted to a trusted recursive resolver. As an ISP, you don't even see it happening because it's in HTTPS. It's all encrypted. So you've done all this work putting in all this DNS infrastructure, and Firefox goes, yeah, okay, thanks, but we're not going to use it anymore. We're going to send all your queries to Cloudflare. Is Cloudflare Mongolian? I don't think so. How do you feel about sending all your user traffic to Cloudflare? How do you feel about telling Cloudflare everything you do? You might feel okay with that, and that's okay too, but you might be worried, and maybe you should be a little bit concerned, because they're not you, they're somewhere else. And this is everything your users do. So DNS within the resolver, within the browser, happening. Chrome, any day now. Slightly different idea, but any day now. So what should you do? Oh, sorry, I'll go back again. What should you do? You might think about using DNS over HTTPS in your resolver yourselves. You might want to turn it on. It's available in bind. It's coming in not. The major vendors are now pushing it out. You should turn it on. It's probably a good idea. Anyone from Akamai here? Ah, Mr. Akamai. Ah, Mr. Akamai. We have a problem. Akamai tried very, very hard to send me to the closest data centre. So I might be in Australia, and I might look for something that's on Akamai's EdgeNet, I'll go to Sydney. In Mongolia, I go to the same URL, and I will go to, I'll take a guess, Hong Kong. Closer. How do they do that? Because they play with the DNS. And what they like is this idea that the DNS actually says who I am, using an extension called a client subnet. Now the theory was that it was just meant to be the /24, just the subnet, as if that doesn't identify me. Most people use a /24, but some do a /32. It's the individual user that's identified all the way through the DNS. Really bad idea. Really bad idea. I know Akamai have built a lot of business on it, but wasn't there a better way? Isn't there a better way? Can't we change this? Can't we make it better for Akamai and better for us as users? Why are we leaking so much privacy in the DNS? Bad move. Shouldn't we all use Google? So many people use Google that my queries will just get lost. Is it better that I share all my secrets with Google and no one else? What a tough moral question. Don't Google know enough already? Why does my data help them? Why should I do this? So hiding in the crowd is very popular. And many, many folk use Google. 20% of the world sends their secrets to Google in real time. 1 in 5. Think about that for a second. And you go, oh, Mongolia's different. Oh dear. No, it's not. It's slightly worse. What that says, if you're looking hard at the print from the back, is that 1/2 of Mongolian users list Google's public DNS as a backup resolver. You're sending secrets to Google at a phenomenal rate. I can tell you who, but I didn't put it on the slide. I was looking. A couple of big ISPs use Google. Think about it. Is that what you want? I mean, you could be okay with that. You could be okay with sending your secrets elsewhere. The good news is that 97% of Mongolians use local resolvers as well, but Google figures high on the list. Too high, probably. Going forward again. My advice to you when you're a service provider and you're thinking about adding all 8s to your list, think really hard about what you're about to do. It might be fast, it might be really efficient, it might be always up, but the DNS is everything. It's everything you and I do. And if you're telling Google it, they're listening because it's valuable information. So what do I do? These days I use Cloudflare. Now I know that's bad. I'm sending all my secrets to Cloudflare. But I really, really wanted to use DNS over HTTPS. Why? I am sick and tired of airport networks and hotel networks and all these other networks that spy on my DNS, mangle my DNS, change my DNS. I don't want that anymore. I want to look like web traffic. So I want my DNS to hide inside HTTPS. So I run Cloudflare. Why? I think it's a compromise between integrity, I get the answers I want, and privacy. Yeah, okay, Cloudflare knows everything about me. Oops. But I traded it off and I run Cloudflare's proxy. You individually might want to think about your options, about where your secrets go. But above all, let me say this once more. The DNS is not fixed. It's a story that we're all writing. As engineers, as people who have spent 5, 10 years learning programming, learning network protocols, learning security, don't think that the rest of us know any better. We don't. We're just like you, and we get it wrong as often as we get it right. If you don't like it, change it. Open source code is there for you. This is about your internet, not their internet. If you don't like it, change it. You can do it as much as anyone else. So think about the internet as an open technology and apply your skills, your training, your engineering, and make it our internet for you. Make it our internet for everyone, because that's what we're here for. Thank you very much.
And now we will take a group photo, and now I'll invite Mr. Iqbat and Nanjit to the stage for a group photo.
After speakers?
Yes. And also our two team's chairs, please, on the stage. Okay, thank you again. Now we have prepared this little surprise performance for you guys. And we prepared our traditional music instrument, Maringhor, and a long song for the opening ceremony. So please enjoy the performance.
За ингээд та бүхэндээ өглөөний мэнд хүргэн төшөөлье. Тэгээд Монгол ардын уртын дуу жаргалтай дэлгэр зам хуурын сайхан аялгау хөвмийн төрөлхийг сонирхолтой болъё.